Okay, we are going to look at question number 36, which has a lot of hidden detail. And as I circle 36, I want to review what we're asked to do. It says solve the following equations on the interval of 0 to 360 degrees, which means set your calculator to degree mode. Okay? Set your calculator and your mind. Alright, here's our mini review. These are the values of your special angles. You must memorize these for mastery. Again, recreate the chart over and over the night before the test, every day until the test, until you have them mastered. It is extremely important. Please look at them written here. The next thing is hugely important is looking to see how do we name angles in specific quadrants. You have to keep in mind how the manner in which we measure angles. Measuring angles must always start from the ground. What is the ground in respective of our x and y axes is the x-axis. And you have to go back and forth between radii and degrees. The positive x-axis has an angle of equal to 0. The negative x-axis, or the left side, has a degree value of 180 degrees, or pi. You have to flow back and forth. So because angles that are measured in the second quadrant require us to rotate counterclockwise to measure an angle, and then since we have to move to the left to find that angle, we must subtract 180. What are we subtracting? The reference angle. Definition of a reference angle is an angle that lies greater than 0 and less than 90, or between 0 and pi over 2. Pi over 2 is the radian equivalent to 90 degrees. So these have to be memorized. Okay, pi is here. Or 180 degrees minus 180 degrees plus for quadrant 3. In quadrant 4, we're actually closer to 2 pi. 2 pi in radians is 360 degrees. These also have to be memorized. And the last concept that must be memorized is where all students take calculus, which tells us which trig ratios are positive in which quadrants. Okay, sine, everything's positive in the first quadrant. Sine is y. Y is above 0, so sine is positive. And don't forget the reciprocal function to sine, which is cosecant. Tangent is positive because tangent is the ratio y over x. Everything else is negative. Left and down are negative. Y over x is our ratio. That's going to be positive. And lastly is cosine. Cosine is to the right of 0, cosine is x, and that's why cosine is positive in the fourth quadrant. We are ready to begin. Here we go. We're going to solve equations. I think I did a little work down at the bottom, which I'm going to hide. Okay, so we're going to make this problem a little easier. We're going to write a let statement and let sine of theta equal y. Substitute, and this is called making a simpler problem so that our focus can be simply on solving for a while, and then we'll go back to this at the end. So this becomes an algebra 1 problem. Undo addition and multiplication first. We get 2y equals negative radical 2. Solving for y, undo the multiplication, and we get y is equal to negative radical 2. I want that negative sign to pop. And I also want to go over here. We're ready. This problem is not y. Look at that concept. This problem is the sine of theta is equal to radical 2 over 2. Okay? This is a minus sign. Again, I want that minus sign to stand out. Now we're ready for some concepts. We are looking for where our angle is negative according to sine. Sine is y. Y is negative in quadrant 3. Y is negative in quadrant 4. And we have our rules written up at the top. So we're going to find theta plus our reference angle, which is your reference angle is what has to be memorized. And in our rule in the fourth quadrant is 360 minus our reference angle. Our reference angle is what you guys memorized. The angle, our reference angle is 45 degrees, so it's going to be 180 plus 45 degrees, 180 minus 45 degrees. Use your calculators, use your calculators. So we have our two solutions, which theta will be, I think I'll write it here, theta will be 225, and the reference angle will be 315. 360 minus. Okay, so I'm going to just box them in, right, and that closes that problem, which I think is, 36A. 36B, because cosine relates to x, we're going to get that friendly let statement, let x equal cosine of theta. Substitute. Solve. Try to make x positive whenever possible. It's easier to think with positive values. We have 4 is equal to 2x. Check your math. Undo addition and subtraction. And we get left to right. Negative 1 is equal to 2x. Divide by 2, both sides, and we get x is equal to negative 1/2. Uh-oh, this is not x. Keep mindful, this is the cosine. X is equal to cosine theta. We are ready to drop it in. Cosine of theta is equal to negative 1/2. Where is cosine negative? Cosine is x, and x is negative in 2 places. Quadrant 2, because it's to the left, and quadrant 3, because it's quadrant 3, x is to the left. What is your rule? Go back to your rule. Quadrant 2 is 180 minus your reference angle. Quadrant 3 is 180 plus your reference angle. What is the reference angle now? Go to that chart that you create every single time you work with special angles. And that should say 60 degrees, because we're in degrees. Copy, and then plug and chug. Your two theta values are, theta is going to be equal to 120 degrees, and theta is going to be equal to 240 degrees. Box them in. Those are your two solutions. And in the words of Jay-Z, on to the next one. Okay, notice I kind of drew some tables here at the bottom. We'll get to that when we need it. Just keep mindful, you always have to go back to the unit circle. First thing we're going to do is, again, you can't convert to sine and cosine. Tangents in terms of y and x, because it's a hybrid. Tangent is equal to the ratio y over x, so just leave it in pure form. We have to address our questions. We now are in radian mode. You set your thinking calculator to radian mode. Please, please look at what you're asked to do. Okay, so in radian mode, -1 on both sides. We get tangent of x. Sometimes they use theta, sometimes they use x. You should not feel stressed. Okay, now we're looking for, where is tangent equal to -1? Well, the location of where tangent is negative in quadrant 2 and in quadrant 4. Remember, that's the ratio y over x. Your x value is a special angle, which has to be memorized. What is that reference angle? It is pi over 4. So x, and I like working in radians, it's easier because you just keep the name. The name is pi over 4. Now, in quadrant 2, we have to look at, okay, what are the rules for writing? That's going to be pi radians minus your theta value. Okay? Okay, remember how to make the coefficient of pi 1. That requires you to know the coefficient is 1, so it's actually going to be to add and subtract fractions. We talked about it, the denominators have to be the same. So it's 4 pi minus 1 pi over 4. And 4 minus 1 is 3. Just went ahead and added that. Very easy. That's your first theta value or x value. And we have to do the next one. In quadrant 4, it's going to be 2 pi minus pi over 4. Again, to add or subtract fractions, you have to have the same denominator. That denominator is 4. 8 divided by 4 is 2. 1 pi over 4. And we are going to get 7 pi over 4. As our second value for theta. And just cleaning this up again so it looks really nice and neat. It is here. I hope you guys are going to watch these videos over and over again for mastery. A's are possible. Alright, in algebra. Here we go. Got our friendly sign. Remember, we're going to have our let statement. I'll put this one in red so it pops out. Let y equal sine of x. Here we go. And I think this makes it easier. Minus, I put a little too many. Just check. Okay. This becomes our algebra 1, which is factoring with a quadratic where a is greater than 1. Okay. I'm just going to undo that so it's less distracting. When you factor, you're going to create 2 binomials. You're focusing on C. C is positives. The sign has to be the same as what you ask? B. So we're going to have 2 negative. And we have to factor our constant. Our constant is 1. So there's only one way to get 1. So this is super easy. And then the other is the inner and outer. I would guess and check. Start it anywhere you want. We want to know this is going to be 2y times single y. And here is where you have to check according to FOIL. It's your inner and outer. This inner is negative 1y. This outer is negative 2y. And add them together. That's your middle term, negative 3y. This is correct. So again, set each factor to 0. So we're going to have the first factor equals 0. And the second factor. Okay. Solve, undo addition and subtraction. I like these because they're the same. And we're going to get 2y equals 1. 2y is equal to 1. Going back to what we're asked to do. This one we have to solve for y, so we're not ready. So we get y is equal to 1/2. And this, here we're ready to go. Y is not y anymore. Y is sine of theta. So you have to know this is going to be, where is the sine of, and I guess they call this one x equal to 1/2. And this one we just write sine, and you can see why I have my grids here. Sine of x is equal to 1. Okay, shimmying down and cleaning this up. All right, so here we go. Again, this is a special angle. Where is sine positive? Sine is positive in 2 locations. Our locations go in this manner. Quadrant 2, because it's y, it's above 0, and everything's positive on quadrant 1. That reference angle, again from that chart, is 30 degrees, but I forgot to check. Are we going in radians? Yes, we are in radians. Always check in radians. That is pi over 6. And a rule for the second quadrant is pi minus your reference angle, pi over 6. You're going to know you have to have the denominator the same. Coefficient of pi is 1. 6 over 6 is equal to 1, which allows us to subtract our fractions. So, and just making this, cleaning this up, x is equal to 5 pi over 6. Okay, last part, okay, is where is sine equal to 1? You got to play this ring around the rosies bit. That's what I call it. Ring around the rosies. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Sign is y. Where is y equal to 1? This is y, no. This is y, yes. Check for more. Y, no. Y, no. We have this. And we are in radian mode, so x is only one solution, and that is in radian pi over 2. So you have 3 solutions for this problem. This is enough, but if you want to write them in a nice organized fashion, which is least to greatest, your solution set will be from least to greatest is pi over 6, 5 pi over 6, and pi over 2. And that is your solution set.